again, I have no aspirations to be a star. People have asked, well, that's why you put stuff out on YouTube, right? Yeah, that's why I do it. All right, but next semester you may find that you need this because, like I said, I'm going to teach the class differently next semester. I'm not going to do much going through the book. Instead, we're going to write program after program. And I'm sorry, but with some of you, if you really type slow, you're going to be left a little bit behind. Because I can't sit there and if there's one of you, I don't know who types fast and who types slow, all right? But I can't give you 5 minutes to type in this. But there's just not enough time to do it, not where you're going to learn things. So what I'll do is I'll always do that, and you'll always be able to go back and look at the code that way if you want to do that, or like that. All right, so before the break, we looked at these. First thing I want to tell you, the while loop is known as a pretest loop. And if you say, I don't know what that means, I'd say, yes, you do. All right? Now, anybody except Ethan can answer this because I already showed it to him. All right? Now, if I do this, it's going to print out just exactly what we said before, LCV equals 1 to 10, right? If I do this, what's it going to print out? It's not a trick. What's that going to print out? What? What did you say? What is the first thing you said? No. I'm waiting for the right answer. No. There. Thank you. The winner. Nothing. Is 11 ever less than or equal to 10? Not in my book. So it's going to skip that. And it's going to go to whatever code happens to be right there. Does that make sense? It's a pretest loop, meaning that you test the condition before you get into the loop. If the condition you're testing is false initially, you don't go into the loop body. The loop body is whatever's in the curly braces. That's referred to as the loop body. If there was only one line here, if all we were saying here was an alert, all right, just that one line, we wouldn't need the curly braces. I'd recommend you put them in anyway. In fact, somebody tell me this. Here's a little redemption chance for yourself, all right? What's that going to print? Anybody can answer that one. Right there. What's that going to print? It's not a trick. What?
What's in the alert?
Yes, but what, I mean, that's, yeah, oh, there you go. All right, what is this going to print out on the screen? LCV equals what? No. 1. But since I'm not changing its value, that's an infinite loop. As soon as you answer it, it's going to print out again on the screen, LCV equal 1. You close that, it's going to print out again, because I'm never changing the value of the LCV. So if I leave this line out, I created what's called an infinite loop. And you might say, oh, geez, that's terrible. It can be a bad thing. All right, I'm going to tell you a very quick story. Back in the day when I was in your shoes, all right, and I was about 22, I was still a punk, all right, but I was going to school. And I did that, and this is back at the time where we had dumb terminals. We were all connected to a mainframe. What happens, the worst thing that happens in here is you put an infinite loop in, you lock up your own machine. Does that make sense? Because the processing power is trying to keep doing this, doing this, doing this. Back then, since we were all hooked up to the same mainframe, okay, I locked up everybody's machine. There were 24 people in the room. They didn't like me that much to begin with. All right, I moved into a different town. I talked a little bit differently and stuff. They liked me even less after I did that. All right, but then eventually almost all of them did it. And then you knew what happened. And what's really bad is if you did that and you did something like that, but let's say instead of this, we'd send it to the printer, okay, and we forgot to put this in there. Now we tell it, send it to the printer. When you get done, send it to the printer. When you get done, send it to the printer. And I don't know if any of you have ever done this, but that used to bug the hell out of me when I worked at Blackhawk. Somebody would sit there and do this. They would do a Control P, to print, send it to the printer. Okay, not realizing that the printer was already screwed up. They'd give it about 5 seconds, nothing's happening. So they'd send it 5 or 6 times. And then once the printer would clear out, and I didn't have permissions. I was not an administrator, so I couldn't clear anybody's out. You see, that's not a bad thing. It was bad when we had one student who came in and printed out a 700-page book. And I came in the next day and there was print paper all over the floor, all right, because they finally managed to fix up the printer. So if you ever have a problem like that, please ask. All right. All right. Does everything that's in here make sense? There's three things you have to do. First thing here, you have to initialize, the loop control variable. That's what we're doing right there. You have to initialize it. Next, you have to test the loop control variable. And finally, you have to change the value of the loop control variable. You have to do that, and it doesn't matter which of these three loops you use. You have to do that every time. Unless you can leave this one out if you want an infinite loop. And you might say, I'd never want an infinite loop. Yeah, I used to work for the phone company. And that was back in the olden days of dial tone. You pick it up and you want dial tone. That code ran in an infinite loop. So sometimes code does run in an infinite loop. All right? Does everything that's in here, I'm asking you this, is there anything in the blue that does not make sense? Anything?
The LCV plus 4.
That's adding 1 to the value of our loop control variable. Remember, that's a shortcut for saying LCV equals LCV plus 1. So that's what's making this print out 1, then 2, then 3, then 4. And eventually, when it prints out LCV equal 10, we add 1 to it, it's 11. Now we say, is it less than or equal to 10? It's not, so it comes and it does whatever's next. Okay? Any other questions? Good question. Pardon?
Like real application, I guess?
Well, okay, that's another good question. What's an application of this? Let me move down a little further. I'm going to grab this. All right, we'll come right back to where we just were in just a second. Okay, let's say that I for this LCV, I say LCV equals, so I'm going to make an array up here. So I'm going to say var numbers equals 1,000. Okay? All right. I'll leave the LCV equal. We'll just say var LCV right there. Just do it like that. All right. Now, I'm going to screw this up because I don't remember how to do it, but I'm going to just show you this. So this line of code is wrong. All right, I don't remember how to generate a random number right now in JavaScript. But what this will do is that'll generate 1,000 random numbers for me between 1 and 100 and stick them in an array. That's a real application. What we're going to do next week is you're going to create an application with me that looks like this. All right. We're going to automatically generate just like this, but instead of this, we're going to do 25. We're going to automatically generate 25 random numbers. Okay. Then we're going to come in here. We're going to find the biggest number, the smallest number, the sum of all the numbers, the average of the numbers, and then we're also going to learn to put them in descending order and ascending order. We're going to do that. That's the array program that we're going to do as a class. That's going to be harder than the program you're going to get on your next test. Yes?
So this would be more like online board games and stuff?
This would be for anything. There's a lot of, tell me if I'm answering your question, many games use things like this, principles like this, yes. And that's why, I'll always remember this. I had a young guy named Jason who came into one of my classes years ago, first day of class. And this side of his head was shaved, and this side was down to his shoulders. So I already knew he was going to be an interesting guy. He was all in black. Today I'd worry a gun in his pant or in his shirt or something, because a really huge black coat on, black army boots. He was brilliant. He was really a smart guy. Very nice too. First day. Okay, when are we going to start programming games? He could have probably done it almost from day one, but he's like, oh, and I hate math. I'm sorry, this is still math. All right? And what I want you to understand is when you do this, now the system is going to try to find, and I can't make 1,000, of course, but it's going to try to find 1,000 contiguous memory locations. And the first one here, this one is going to be numbers sub 0, and the very last one will be numbers sub 999. Does that make sense to everybody? Because if you get that, you're on your way to understanding this stuff. All right? So I hopefully that answered the question as far as an application, because we are going to do that next week. All right?
Random number generator between 2, 7.
Well, again, if I go in here, I can type in generate random number
It's like math.
between, it's between 1 and 10, and let's say 1 and 100 in JavaScript. All right, and it's going to show us in here the random method, and it's math.random, okay? So notice there's a number between 1 and 10. I don't want to take the time to explain that right now, but if you look at it, it actually sort of makes sense. So if I do this, that's actually correct. I have to make that 100. That will generate 1,000 random numbers between 1 and 100. So if I wanted to write a program that would show how, be showing coin flips, okay, I could make that I could either what I do would probably be to make it a 1 right there. I would add 1 to it, and if it was 0 it was heads, 1 it was tails, or vice versa type of an idea. Somebody else had their hand up?
I was just a question, like whenever you're explaining it, I get it. Like when I'm following instructions in the book, I feel like I'm getting it. When I get instructions, I feel like I just feel blank. Are we able to like start doing more hands-on as a class? Like
Yeah, that's what we're going to do next week, and we're going to do 1 or 2 simple array programs, and then we're going to do a more exhaustive array program. All right, because to me, when you get to this point, I was telling Ethan during the break, and just so you all hear, when we get into Chapter 4 and we do a debugging exercise, it's going to be hard, but it's going to be harder than when you actually get on the test. And once you understand it in class, it should be much easier to understand it on the test. All right, and think about how far you've come. I don't want to sound like your dad or something like that, but when you walked in here day 1, and you look at what you're creating now for websites and the like, well, you're only 2 or 3 weeks into JavaScript. The idea is you're not going to become JavaScript masters. You don't if you know 100% of what's in this book, you're not a JavaScript master. And we're actually not going through the hardest stuff, which is 8, 9, 10, 11, and 12, because there's not time. All right, but it's probably better this way, because at Blackhawk, I had 2 classes, one which was just an HTML class, one which was a JavaScript class. And we got to that point where you get to the hard stuff, boy, people were just getting confused as heck. It was very tough. That's why in that program, I'd start with 24, and I'd usually be down to 12 to 15 after the first semester. It just was too hard. All right, so we come back up here. Any more questions? Because you're asking good questions. Any more on this?
Does the order matter?
These 2?
Yes.
No, that's a good question. The question was, does the order matter? The answer is, in this case, if we flip these, it's going to, instead of printing out 1 to 10, it's going to start with 2. See that? Now, there's all sorts of ways that you can dicker with this, just so you know. And I don't want to go through them with it because I don't want to confuse you. I'm trying to show you what I consider to be the most straightforward way of doing this. Amin asked this. If it's easier for you still, remember, you can do this. And I don't mean to say that that's what you were saying. But you can do that. If that's easier for you to be doing it like that, writing it like that, then write it like that. Or if it's easier for you to write it like this, remember, you can also say plus equal 1. That's fine. I want it to be easy. I want you to understand what you're doing. And that kind of goes back to the point Tiffany was just making. If you are doing something, and that's why, have you noticed, this is probably the most interactive class we've ever had, and that's good. I'm energized now, and that's good, because I have to drive 300 and some miles this afternoon. All right, so that's good.
Nice.
Yeah. Well, it's because of your damn Cubs.
Sorry about it.
It's because my daughter's friend who had agreed to drive, and I was going to go with the 2 of them, she's down there in Chicago right now, because she had to go, because starting in, this is going to be on tape, Brittany. So, because starting this semester, or this year, as soon as they got good, she's now a Cubs fan.
Oh,
All right? People who have been Cubs fan for years, I'm happy for them. People who jumped on the bandwagon, that's what I say to them. All right? Just so you know.
Agreed.
Yes.
It's like
And go-karts, even though I'm from Milwaukee. Go ahead.
LCV plus 2. Is that 2 at a time?
This,
Like,
if you put a 2 in there, if I only wanted to print out odd numbers, that would be how I do it.
I got you.
So I'd print out, et cetera. All right? Now, if I did this, and I said 10, it's only going to print it equals 1, and it's going to add 10 to it, making it 11, so that's going to fail. So there's all sorts of different things that you can do with this. All right? But the one thing is, and I'll take your question in a second, you shouldn't be jacking with that LCV except to change it. You should only change it in one spot. All right? What we're going to get to in just a minute, and then I'm going to take your question, is what if for some reason I wanted to say, when you got to 7, just stop. You understand what I'm saying? When you get to 7, stop. All right? Then I could come in here and I could say this. If LCV equal, I should be really saying 3 equals 7, break. Now it's going to only print out that. As soon as it gets to 7, it breaks out of the loop. Break means get the heck out. There's another one that we're going to see in just a couple minutes. Instead of saying break, if I say continue, not continue, continue, then it's going to print all this, but it won't print out this one. It's telling it to skip that one. And you're going to see that in just a minute. Okay? Yes.
You had you just said that the odd numbers thing, if you put 2,
Yes.
How would you start that to make it so it's all even numbers?
And you just
Change
start that
to
with
0?
either 0 or with 2.
Right, okay.
So again, Drew, this isn't exactly what you asked, but what if I wanted, for some reason I'm trying to teach a youngster something, okay? And now I can come in here and I can do this. And now I'm showing them all the even numbers between 2 and 100. See what I'm saying? So if I was doing some kind of an elementary math game for kids, or so maybe it's just going to be the even numbers between 1 and 10 or something like that.
That's pretty much what I was asking.
Yeah. Okay. Anything else? All right, so let's go on to the next one. Remember I said this right here, pretest loop? Now when we look at this one, post-test loop. Look at the difference. I'm going to give you a hint. I'm asking you a question. I'm going to give you a hint. The answer is not 0. How many times do I go through that program? The way it's currently written. 0 times is not correct. When are we making the check? At the end, correct? So it's going to print out LCV equal 11. It'll add 1 to it, making it 12, and then it'll fail. So if you want to make sure you always go through the body of a loop, you use a do while as opposed to a while. Almost always, literally 99.99999, etc. % of the time, anything you can do with a while, you can do with a do while, and vice versa. There might be exceptions. I've never tried to figure out what they are. This is also the only time, and I guess what you were saying, Drew, is the author might not show it spaced and stuff exactly the way that I do it. I think the author shows like he's got his curly brace there, and he might even do something like that. It doesn't matter. All right? I do it like this, the way I do it, because that's just because of the way I do it. This is one of the few times when I learned this stuff that the instructor said, do it whatever way makes the most sense to you. And to me, that's the way I should tell you to do it the same way. But this is the only time where the condition comes at the end, and there must be a semicolon at the end. If you try putting a semicolon after the while, it won't work. If you try putting a semicolon at the end of for, it won't work. All right? And when people say, well, then what will happen? Then try it. And you'll see what will happen. But sometimes what people do is they want to test this code, but it's error code. So in an ideal world, error code will never run, correct? In an ideal world, it's like error code in a computer, if you don't realize this, in some applications, up to 80% of the code that's in a program is error code. You're checking for possible errors. And the more you ask humans to interact, the more errors you're going to possibly get. Because humans make mistakes. Or they just try to say, hey, I wonder what would happen if I did this. And I've given this analogy before. Error code is like car insurance. I'm not asking, but if I said, how many of you have car insurance? Every hand at least should go up, right? Okay, so you buy car insurance, you pay thousands of dollars for it, but would you agree that your goal in life is to never have to use it? That's what error checking code is. You put it in there because if you need it, you might need it bad, but ideally, you're never going to need to use it. All right, but it's what do they call it? Unnecessary evil. All right, and again, that's just the way that it works. So with a do while, you must go through the loop once. So sometimes what people do is they take their error code and they put it into a do while loop to make sure it runs. Once it runs and they're happy with it, they convert it back into a while loop. All right, there's nothing wrong with using do while. There isn't. Some people find this kind of logic easier to work with. If you're one of those kind of people, that's fine. Doesn't mean there's anything wrong with you or anything like that. It's like when I was a little kid, because I'm left-handed, people told me that there was something wrong with me because I'm left-handed. All right? And I said, no, only 9 to 10% of the people in the world are left-handed. So we're all special. All right? Yes?
Pretty much all these loops do the exact same thing, it's just picking the one you feel comfortable.
Yes. Now, that was a good lead-in, because Tiffany just asked, with all these loops, they do the same thing. Use the one you're comfortable with. That is true. But let's assume for a second I work for an insurance company. I'm a programmer for an insurance company. And I've given a file, and that file has in it people who've been added to the company, people who have changed their names, changed their addresses, whatever, and people who have left the company. Would you agree that there's a very good chance if I read that file at the beginning of the program, I might not know how many people are in there? Would you agree with that? All right. The reason I'm telling you that is then I cannot use this loop. The for loop is called a counting loop. With a for loop, you need to know exactly how many times you're going through it. With these two, I could put conditions on here, and instead of saying this, and instead of saying this, all right, sometimes what you actually see in code is something like this. Anybody know what that stands for? The exclamation point is a not. While not, end of file. EOF. You cannot use an EOF with a for loop. The for loop, like what we saw before, the for loop is another pretest loop. So if this is 11, you're never going to go through the body of the loop. Does that make sense to everyone? Because you're initializing. See, you do your initialize, your test, and your increment or decrement in the same line, as opposed to doing it in 1, 2, 3 lines. So you write less code with a for loop. But you need to know exactly how many times you're going through it. So this will give you, this right here, will give you this. It will give you that. All right? Typically, most programmers use a for loop when they can because it's less code. If you're writing a humongous application that's got thousands of lines in it, and you can cut it, maybe you've got 100 loops. That's 200 less lines of code that you write with this. All right? And typically, because all the stuff is kind of scrunched together, the way that the computer actually goes and references this stuff down to zeros and ones, typically this will go faster than the other ones will. It's just the way that it works. Why? Because that's the way that it works. So they talk about the while loop on 163, 164, 165, 166, 167, 168. All right, then they go into the do while loop on 169. Please look up on the screen here. I just want to show you one thing. Does this make sense to everyone? You all said you're kind of comfortable now, or at least no, there weren't any other questions. So LCV less than or equal to 10. What if I did this? You all agreed that if I do this, this is going to print this. Okay, everybody agreed with that. What if I want to print, I'm doing a simulation for a rocket, and I want 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, okay? Then all I do is I start it at 10, and why I say while it's greater than or equal to 1, and instead of adding 1 to it, I subtract 1 from it. Does that make sense? So you can go in either direction, all right? And again, because the question got asked before, that could be here. I could make that 100. I could make that a 2, and that would give me every even number from 100 to the 0, starting with the biggest numbers. Yes.
You start in the middle.
Well, you could start in the middle, but you would only probably start in the middle if you wanted to either go and do the top half or the bottom half.
How does the computer know that it's asking for the number just because we used 100?
In this case, the only reason that you're starting with 100 and you're saying subtract 2. 100 minus 2 is 98, minus 2 is 96, etc. So again, if I wanted everything, I could start with 99, and I wanted every value that I was positive that 3 would go into. Okay? You ever hear that rule with numbers? So if I want to know if the number 1,287 is divisible by 3 or not, I add 1 plus 2, which is 3, plus 8, which is 11, plus 7, which is 18. And I add the 1 and the 8, I get a 9. You keep adding the numbers together. If you get a single number. If that single number is 3, 6, or 9, the number is divisible by 3. I had to take a class senior year in high school called Topics in Math. 18 weeks. That's the only thing I learned. But I learned it. And he taught us that the first day. Really. But it was a blow-off class because I needed one more class to graduate. All right. So the for loop, again, just like the while, except you do everything. You do the initialization, you do the test, and you do the increment or decrement on the same line. Okay? Now, I want you to see this just so you have seen it. If I do this, and this is going to look weird, so I'm just warning you. If I said this, let's just say I said LCV equal LCV. Well, it's like, why would you ever want to do that? Isn't it always going to be true? Yes, that would do an infinite loop. What's that? No, that's, if you want not equals, that's this. And that's strict not equals. And that's strict equals. All right. 2 equal signs are that's assignment. That would say take LCV and set it equal to itself. All right. But the reason I'm showing you that is sometimes what you see in actual application code is that's how you write an infinite loop using a for loop. You have no initial condition, you have no test, you have no increment or decrement. Now, you used to be able to write in any programming language. This is way too hard to do. You could just write this. But I've tried doing that, and you get an error message in JavaScript doing it that way. All right, you can still do it in other languages. All right, but I don't know why, but you get an error for doing it in JavaScript. All right, so the do while is on 169, 170, 171. The for loop starts on 172. The for loop starts on 173. The continue that I showed you starts on 178. And then we get to the if statement, which gets us to page 180. All right? So let's talk for a second about that. All right. Somebody asked a question before, Tiffany, maybe it was you who asked about that. How does a computer know this, et cetera, which was a good question. But if I do this, I want to go back to that thing I gave you earlier. There. So I'm literally writing this program on the fly. And I'll put a little comment here that says, generate a random number between 1 and 100. Okay? Now, if I do this, if x modulo 2 equal, I think 3 would work, I think. And actually, writing it like that, that's not very good, because all it's going to say is the number is even. Why don't we put the number down? So that's going to give me a, every time I run it, it's ideally going to generate a different random number, right? So the first time I run it, it might say 37 is odd. The next time I run it, it might say 64 is even. I can put this into a loop, and again, I can take these numbers and put them into an array like we looked at before. So let's grab this. Oops. All right, var number is equal, yeah, RLCV, yeah, that's fine. Now, how long did that take me? A minute? Now I can run that program 1,000, it's going to give me 1,000 different numbers that it's going to say. I wouldn't probably use an alert because it's just going to keep running like that. So I'd probably stick it into a string or something like that. But you ask for some real life applications, that's how you use it. All right. Again, they've got the continue and the other stuff. All right. But does this make sense? The key thing to realize, and I'm going to explain this to you fairly quickly, but if you understand everything I'm about to tell you, you've got if and else statements down. All right. The first thing is, whenever I run this program, this line must print or that line must print. Does that make sense? Only one can print, but one must print. If the condition is true, then whatever is under the curlies by the true will print. If the condition is false, then whatever under here will print. All right? What if I did this, and what if I didn't add 1 to it? That's going to give me numbers actually between, I think, like 0 and 99. All right? So what I might do first here is I might check. I don't want a semicolon there. So I might check here, and I might say this. Let's move up. If, let's just grab all this. And I can keep that too. Now, if it's a 0, it's going to print out 0 is neither odd nor even. Does that make sense? All right. But notice we say we get an if and as many else ifs as we want. You can only have one else. And if you use it, it must go at the bottom. But I can have as many else ifs as I want to or need to have. Also, if I have one or more else ifs, it's not mandatory that I have an else on the end. I can have an if by itself, an if with an else, an if with an else if, an if with multiple else ifs, and an if with an else if or multiple else ifs with an else. All right? Yeah, there's a lot of possibilities. No, there is.
That's like a tongue twister.
Well, let's say that we're a 4-year institution, and I could say here, if your year is 1, you're a freshman. Else, if it's 2, you're a sophomore. Else, if it's 3, you're a junior. Else, if it's 4, you're a senior. Else, maybe you're just an auditor or something. So there's a lot of different ways that this stuff is used. And what you're noticing too is I'm putting ifs inside of whiles. That's called nesting. And I can put anything. I can put an if within an if. I can put, a while within an if within a while. You can put a while within a while. All right? And this is an old joke, so you might laugh. It's not really funny, but it's the old joke where the computer always knows what you're trying to do, even if you don't. In other words, it's got to literally take whatever instructions you give it, even if they don't make sense. And it has to try to work with those. And it will. All right? Yes.
You're talking about putting that as an alert, and it'll just keep coming up, I guess, upon.
No, this will keep, yes, you're right.
Yeah, upon
But
click, if
on here, I'd have to come back and say, as soon as I say here, LCV++, now it'll stop after 1,000 times.
it'll stop after 1,000 times, but that's like, what you're actually doing, like interacting with that, I guess, you're just sitting there.
No, you're only run it once. When you run it, there's nothing you have to do. What we're going to do, remember that I told you what we do next week, where we'll find the biggest number, the smallest number, etc. We'll immediately show the 25 random numbers that were generated. Then we'll make a real simple little menu that'll say, like, enter a 1 if you want to put in, if you want 25 new numbers generated.
Right.
Enter a 2 if you want to see it in ascending order or whatever.
Okay, you said you wouldn't necessarily want an alert, you'd rather have a string. What does it look like with the string?
For what?
Just in there, I guess, right?
In here, no, what I said was, that's an actual number.
Okay.
All right, so anything that's an actual number, you shouldn't put in double quotes.
Okay.
All right. I mean, again, JavaScript is so lenient that this is one of the places where you can break rules and it'll still work, typically. Because unlike other programming languages, what JavaScript tries to do is it tries to figure out what you meant. And it'll do the best it can. Usually it'll guess correctly, but not always. So if you want more on if and else if and a nested if statement, etc., all right, that gets us all the way through to about page, I'm still going. Oh, I wanted to get to the switch statement, all the way up to page 192. So that's about 30 pages worth of the chapter that I went over the way I went over it with you. All right? Now, one more thing I want to say, that we can take another short break, but let's see. I'm going to grab that code right here. It's more than I need, but that's fine. All right. And I want to show you, too, because a couple of you have sort of asked this, but I'm going to say here, var hours equals 0. Var minutes equals 0. Var seconds equals 0. All right? So I'm going to see how many lines this takes me right here. I probably just kill all that stuff now. So while hours less than or equal to 23, while minutes is less than or equal to 59, 9, 9, Now let's count for a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 lines of code. That's going to print every second. It's like I've got a thing going every second. So that's going to print 0:0:0. It's like a clock. And when it gets to the end, it's going to print out 23:59:59. All right, it's not important that you write this program down, but it's important that you understand the logic. So this, when we start, this is 0, correct? So hours is 0, minutes is 0, and seconds is 0, because that's what we set them up to be. So the first time it gets in here, that's true, that's true, that's true. So it's going to print out 0 for hours and a colon, and 0 for minutes and a colon, and 0 for seconds. That makes sense? Then it's going to go and it's going to add, and I didn't put the pluses in here, so that's on me. So I have to put in seconds plus, sorry, minutes plus, and hours plus. Normally you write it in a for loop and it looks a little cleaner when you do it that way. In fact, let's see. I don't know. It's close. If it's not there, it's close. But the point is, so this is going to run. It'll be 000, 001, 002, 003, all the way till it gets just like a clock, 0059. Then it'll be 010, 011, all the way up to 05959. Then it'll be 100, 101. It's just like a clock. But it's using nested loops. So this is going to sit there and, okay, as long as this is true, it'll do this. As long as this is true, it'll do this. And it'll keep doing this, so it's got to work from the inside out when you're working with this stuff. Yes?
So if you put 12 there instead of 23, be out of military time?
Yeah, I used military time. What you could do is we could sit there and do a little bit more work and put an AM and a PM in there to make it look like a regular clock. You could do that. It wouldn't really be that hard, but I knew I could show it like this in just one screen. All right. What if I write code that looks like this? We're going to quickly look at this, then we're going to take a break. If I say if size equal, we'll say here S, alert, you're small. Cheat a little bit here. Small, medium, large, extra large. We'll leave it like that. In fact, let's keep it real simple. We'll assume that in our clothing line here, we only have small, medium, and large. That's it. So I'm going to change all these. So you're a small, you're a medium. If that's an M, and if that's an L, you're a large. That makes sense to everybody? So if I came through at the beginning and I said var size equal medium, that's going to print out on the screen then an alert that says you're a medium. Again, that should make sense to everyone. And there's absolutely nothing wrong with doing it that way. That's totally fine. But I want to show you another way that can be written, because this pretty much ends the chapter. So I'm going to come back in here just like we had, and we'll do that. But I'm going to say what's called a switch on size. Steal these. So let's assume that we don't cater to people who are extra small or who are extra large. All right? So if we did that here, we said small, medium, and large. In fact, these don't have to be ifs, do they? That can be else if that. Else if that. And we're going to say else here, alert, sorry, we don't carry your size. All right, so that'll handle everybody. Here, what we do is, there's no else, it's called default. Now, I don't mind at all that you're writing this down. That's fine with me. But just so you know, there are examples of all these in the book. All right? So if you want to see some stuff, switch statements, it starts on 192 in the book, and there's a program that uses states on pages 194 and 195. All right? But this works just like it's in some books call it a glorified if. So it's going to check, and it checks on what the size is. If the size is small, and I made this single quotes, it could have been double quotes, it doesn't matter. This one, since I put a single quote in here, with this one, I either need to use double quotes like this, or remember, if I'm going to use single quotes, right now that'll fail. That will fail unless I do this. Okay. So this one, it'll check, and it says, is the size, in fact, that wouldn't be a medium, would it? It would be an M. All right, so it's going to say, is the size S? No, so it skips that. Is the size M? Yes, so it does that, and then it skips this, and it skips this. But if the person happened to be an XL for an extra large, it's not that, it's not that, it's not that, so it's going to print out, sorry, we don't carry your size. And in here, if that's an M, and I'm sorry, I should have made that an M. Oh, here I did make it the names. Okay, DIUM. So here, if it is a medium, it skips that, and it does this. No one's asked, but what about that word break? If we left the word break out, all right, so if we left it out of here, and we left it out of here, and we left it out of, come on, here. Technically, you can leave the one off after the default because there's no code that comes after it. But if I did that, and we had this, guess what would print? It would say, you're a medium, you're a large, sorry, we don't carry your size. Because it wouldn't break out of the switch. Remember that break I showed you before with the loops? It's working the same way in here.
Is it the same bracket?
It's because it's within these curlies. But what if I wanted to do the same thing? What if I had one size that handled both small and medium? Okay? Then I could do this. You're a small medium, all right? But you get the idea, all right? So that would say if it's this one or it's this one, do this. Then break after it. Yeah, you'd still want to do the break. Thank you. And that's something that a lot of programmers forget to do. And maybe I've told you this, but I'll always remember this. We got called in for a staff meeting when I was at AT&T, and I started in February, and this was in May. All right? They had code like this to run your telephone. The person who ran it never put that in there, never put a default statement in. They tracked the person down. No, it wasn't me, but they tracked the person down. So why didn't you put a default statement in? And his answer was, because it'll never happen. It happened. It happened, and it was the Friday before Mother's Day, right outside of New York. So what happened was this code got into an infinite loop, and no one could use their phones over the weekend. And if you don't know this, your kids are too young, I guess, but you'll learn that with that's the one time when kids have guilt, and when their parents, when they don't live in New York, they can't call their parents. They figured they lost $5 million over the weekend because the person forgot to put a default case in there. And you might say, well, that was $5 million back in 1982. So we're talking 30-some years ago. Probably it'd be about tenfold right now. So the point is, always put a default in. Always put a final else in, even if you think it'll never happen. Even if you just put down something like, this should never be hit, and you break out of it. Yes?
Just in general, when I'm looking at that, so I'm picturing like this linked list or something. Does that make any sense? Like
Okay,
small, medium, large?
you tell me if I'm answering your question, okay? What we'll do next semester is you will literally have what's called a list box up on your screen.
Right.
And it might have in there small, medium, and large.
Yeah.
And you click on one of those and you click a button and it'll tell you what size you chose.
Yeah.
Now, what we get to in the following semester is that's too much work, because you shouldn't have to enter those values in there. So instead, what we'll do is we'll get those values from a database and we'll have it populate that list for us. All right, and then when we choose something, it'll tell us that information. What's that? Yeah, but we'll have the code write the queries for us.
Gotcha.
All right. And as far as I know, at least, that's it for the chapter. All right? I think we've covered everything. We're up to the end of the chapter.
That's like select this, like radio button.
Yes,
Alright.
yes. And actually, you can do that. And we will start to do stuff like that where you will say things along the lines of you will check, different, what am I trying to tell you here? There's like properties called like is selected, and that'll be the radio button or the checkbox or checkboxes that are selected. All right, you'll learn how to do all that stuff. Yeah, that's what we're moving towards. You can do it in JavaScript too. We'll do that. We'll come back to forms again, and we'll figure out what people have done in their forms, because we'll have JavaScript go through it, and we'll have, for example, like a checkbox that says what's the best time, or what's a radio button, what's the best time to reach you, morning, afternoon, or evening. We'll have the program then run through, and it'll figure out that for us. See what I'm saying? And we'll do like an is selected type of thing. All right? And there are hands-on as always. So the hands-on here start, it looks like, on around page 206. So you're going to be still working, at least the first ones, they'll be working with things you've already worked with, but now you're bringing control flow in, where you're able to do something more than once, which is one of our loops, or you're able to do something where you ask a question, and that question must be true or false. I didn't go into the big thing in here with truthy and falsy. All right, it just was kind of silly to do that. Now, you might think, well, we've fallen behind. I look at it the other way. I look at it that if this stuff is making sense to you, then we have to spend more time on it. Because you're going to do this stuff in every language you do. Everyone. The syntax may be different, but you'll do it the same. So we've done this, we've done this, we've done this. All right? I'm going to push this down a little. We're going to take a break right now, and at 11:30, I'm going to do the test review for the chapter. Then instead, we'll pick up the calculator on Monday. So that'll push this stuff down. All right? I don't care. We'll still get it all done. We somehow will. I might not be good enough. You are. You'll understand it, because I think as we go on, you'll understand it more and more. All right, so let's take a break. Like I said, it's 11:13. At 11:30, on this clock right there, I'm going to start doing the test review. All right? And I'm going to send those to you right now. Not even going to log out.